Warning, all attendees are in listen-only mode.
Hi and good afternoon, everyone. Welcome to our technical webinar today. My name is Julianne Grant and I'm with Adaptive Corporation, and I'll be your moderator for the duration of this webinar. Just a couple of quick housekeeping tips. We are recording this webinar and we'll make it available to you within 24 to 48 hours. We can take questions during the webinar, so if you have one, please use the question panel in your GoToWebinar screen. We will also have a Q&A session at the end of this as well. So let's get on with today's content. We're excited to have our presenter, Kevin Waugh, with us, who will share with you the latest approaches for advanced composite design with laser projection. Kevin recently joined Adaptive to head up our engineering services team and is a wealth of knowledge when it comes to digital product development, such as advanced shape styling, model-based definition, and composite design for manufacturing, which is what we're talking about today. Before joining Adaptive a couple months ago, he was part of the systems engineering team at Sikorsky Aircraft, responsible for supporting the usage of CATIA V within their PLM environment. So with that, we're going to I'm going to hand it over to Kevin, and we're going to get going. Kevin, you're on.
Thanks, Julianne, and hello, everybody, and welcome to the webinar. So today's subject is going to be CATIA Composites laser projection, and I'm going to go through this. It's going to be a technical review. Go through this in about 40-45 minutes and try to leave some time for question and answer at the end. So I'm going to jump right in here. This is something that is new technology, a new application in both V5 and 3D Experience. This is beginning with V5-R2016, which is expressed as V5-6R2016 at the Service Pack 3 minimum level, and also 3D Experience 2017X. And I want to make note that this does exist in 3D Experience 2016X, but with limited functionality. 2017 is the recommended minimum level. The product trigrams for this are CLA for V5 and CLJ for 3D Experience. The PLM Express equivalent for the V5 level is LPX. All right. So I'd like to take a few minutes up front to provide some background. First, some common applications for laser projection. This is commonly used in aerospace in the manufacturing of various components, airframe, nacelles, wing structures, etc. Automotive, at the moment, these components shown here in this little image along the top of the vehicle, for example, a hood or a roof structure, roof panel. Blades, which I'm showing here an example from wind energy, but certainly also for helicopters. The marine industry, particularly boat hulls, and perhaps other applications, and I'll be giving out bonus points at the end of the presentation for anybody that gets this joke. So for anyone that might be new to composite part design, I don't know if that's anyone on the call currently, but you never know who might watch this in the future. Just a quick overview of how composite parts are made. For this presentation, I'm really only concerned with the type of composite parts that are at this time suitable for CATIA, which is to say most composite parts. Just want to run through these real quick. First, there's braiding, hand layup, resin transfer molding, tape laying, and finally fiber placement. So let's quickly review these. First, the braiding. Dassault Systems has recently introduced a product called CATIA Composites Braiding, which I intend to review in a future webinar, so be on the lookout for that in the near future. This is technology that provides the ability to simulate the radial braiding process, and I have an image here coming out of the application as to what that looks like. For anybody not familiar with this, these types of parts are made by interlacing multiple yarns over a mandrel, and ideally that mandrel would be robotically fed through a braiding machine, and around the perimeter of that it would have an array of carriers for multiple strands of yarn, which is what this is shown. So the design process is progressive. It's beginning with the definition of composite parameters, moving on to manually creating plies along the tool surface in CATIA, running producibility analysis, followed by some optimization of speeds and feeds, and results visualization, and finally creating the braiding mesh digitally. Next process is resin transfer molding. It's a process that combines dry fabric and liquid resin within a closed mold. It's well suited for parts with large surface areas that would require smooth finish, such as the hood of a car. So the solution for this is called PAM-RTM. It's from a partner company, ESI. And what this does is extends the capability of CATIA to provide the simulation of resin flow through the fibers in the mold. And here we see a screenshot of analysis results of that integrated in CATIA V5. And lastly, the tape laying and fiber placement. These are complementary methods using computer-guided robotics to place composite material onto a complex tool. Again, another partner product, Cat Fiber, and this is from Coriolis software. And again, integrated into CATIA as a means to design, simulate, and ultimately generate tool paths that are specific to these types of parts. And we get to hand layup, which is really the focus of today's webinar. So I'll take a minute to review the hand layup process. This begins with fabric on the roll, typically pre-pregnated with resin, often referred to as pre-preg. And here I have a little image of two operators interacting with these rolls of material. On the right, she's rolling out the material onto a table, and on the left, this person is kind of leaned over the table, likely trimming the material to create individual cut pieces, which are predefined shapes in flat 2D to be draped onto a contoured 3D tool. At a very basic level, this is the process. So often a Gerber cutter will be used for better accuracy and speed of generating those cut pieces, and that's going to give you the ability to have numerical control over a knife blade that passes over the table in the XY plane. Typically these pieces, once laid onto the tool, are vacuum bagged and very often placed in an autoclave for a period of time to increase the temperature and pressure, cause the resin molecules to cure and bond together, and ideally result in a bonded part without any internal voids. So, why composites laser projection? Well, this is to provide a true-scale digital template for the manual placement, or what we would call hand layup, of composite plies onto the tool or mold surface. The important takeaway here is that this is a digital template as opposed to a physical one. So on the image on the right, I have a laminator who is laying plies onto a tool, and in the room above his head are two laser projectors mounted in the ceiling as well as a console behind him. It's important to note that there is more than one laser because it's common that a single projector can't reach all the areas of the tool, which I will show in a little bit once I get into CATIA. I've also included a little animated GIF here just to illustrate the positioning of a ply or cut piece within that laser projected outline of the intended shape. So what are the benefits of this? Well, first is reduced cycle time. This is a dramatic improvement compared to using physical templates. So traditionally mechanical templates made from paper, metal, plastic, they'd have to be positioned on the tool, or there would have to be measurement instructions provided for each layer. Larger parts would require more than one person to do this. Things like fabrication, storage, design change management, all this made is very cumbersome. Higher precision, which really speaks for itself. A laser beam is much more precise than a fabricated template. It's cleaner, which greatly contributes to the reduction of foreign object debris in the shop. And finally, you have much better repeatability overall. Okay, so why CATIA composites laser projection? The first reason is automated data transfer. What do I mean by this? This is information defined in the CATIA part model that we can directly use to indicate how the part should be laid up. First, we have calibration points, which is how the lasers in the room can locate their position relative to the tool. There are plies themselves, along with any possible cores and cut pieces. And it's worth noting here that cores are taken into account here. We have the rosettes, which in layman's terms refers to an axis system, and that's going to be the way that the fiber orientations are measured, point of reference. The C geometry, which would be a point and possibly a curve that determines the location of where the fibers of the ply do not experience any shearing, and also this typically relates to the way location on the tool where perhaps the smoothing of the ply typically would begin. Order of drape, which would optionally help to define regions of the ply that should be smoothed out in a particular sequence. Any text that we might want to add to pass along semantic information to the laminator, such as the ply name. And finally, we have custom geometry, which could be any collection of points, lines, curves, etc., that would help to communicate between engineering and the shop floor. These things work together to contribute to a model-based workflow that might eliminate or reduce the need for ply books. Some other advantages, the ability to have core sample driven offsets. This really becomes more significant for thicker laminates and possibly parts with high curvature, where the plies that are being laid up on the tool can no longer be assumed to rest upon the tool surface itself, so there would need to be some elevation that those plies are projected at. Again, also taking into account core inserts if the part contains one or more of those. This works together with the laser discretization, which is always a tough word to pronounce, which we have the ability to influence. It's a nice feature to have, and so is the ability to optimize the projector locations. It helps to be able to digitally mock these up within CATIA before committing to where the tool and the laser heads are going to be located in the shop. We can visualize the laser rays, which is great, especially working with multiple laser heads. And lastly, the ability to import legacy files. Vertec, LPT, assembly guidance, and LEP formats are all supported. Finally, a big reason why CATIA Composites laser projection exists is that Majestic Systems is no longer a Dassault partner. They were recently acquired by Autodesk and are considered a legacy solution as of R25. So how does this work? The laser projector application extends the functionality of the existing CATIA Composite workbench or application as it's known in 3D Experience. I'm going to use the V5 toolbars to provide a quick summary of what the commands are, and within the manufacturing toolbar, which is an existing toolbar in CATIA Composites, there's going to be 2 additional buttons here at the end, and in the data export toolbar there's going to be 3 additional buttons. First, we have additional geometry, followed by stacking text. Again, these help to reduce dependency on ply books. Within the data export, we have the laser projector command, followed by the laser projection export. I'm going to be reviewing these dialog boxes. And finally, the imported file reader. And that's it. So now let's look in CATIA. Just a quick note here, since I'm going to be showing both V5 and 3D Experience, I want to point out that although there are differences in the GUI between these 2 versions, the presentation of Composites data has essentially not changed. So here on the left I have a screenshot of the V5 spec tree, notably the composite specifications, which for anyone that's worked with this workbench, this should look familiar. On the right, this is a screenshot from 3D Experience. Aside from being more monochromatic, possibly these cosmetic changes here to the icons, they're basically the same. And as I expand sequence 1, we can see that the presentation of the composite data is unchanged. Ply 1 that we see here has some cut pieces, and for the benefit of anyone new to CATIA Composites, this is how all the geometry and the attributes that define a laminate are organized within a CATIA 3D part, regardless of the version. All right, so now I'm going to jump over to CATIA V5, do a little bit of a live demo. So here we are in V5. I have a little sample part that has a tool resting on a cart. This is all just in one single cat part. If you look in the spec tree, you can see that I already have a couple of laser projectors that are predefined at 60 and 120 degrees. And so the first thing I'm going to do here is demonstrate how to create a third projector that's going to be 90 degrees to the tool. And it's going to fall between these other two that you see here on the screen. And then I'll go through the import and export capabilities, and I'll do this within both V5 and 3D Experience. So let's get started with that. First thing to do in V5 is to activate the license. This is a shareable license in V5, so go into the Tools options here. Prerequisite for it is the composite design for manufacturing, which I'm currently running. You can see that here. And so I'm just going to scroll down and locate this license in the list. There it is, CLA. Go ahead and click that. While I'm here, I'm going to click the one above it as well, CFM. This is a different license that provides additional capability for simulating draping and the producibility. The reason I'm going to activate this, some of the plies in this model were defined using these algorithms in this license. Just want to make sure I want to have it active just in case I want to update any of those plies. So once I do this, click OK. All right, now you can see those extra buttons pop up on these two toolbars that I have here on the screen. So let's create a new laser projector. First thing we want to do, go ahead and launch the utility. All right. And the dialog box at the top has a field for target points, and so I have those already predefined in the tree. I'm going to go ahead and populate this, pick all 6. As soon as I do that, you start to see something happen on the screen here. We get a preview of this projector that I'm making. And I want to point out that each one of these points can be controlled as to whether or not it's taken into account for the laser drift. By default, they're all saying yes. I'm going to click no real quick because I just want to illustrate where this information goes. So the drift would be something that the projectors are programmed to check for in the event that maybe the tool gets bumped or something gets moved out of place. And so I've clicked no to target point number 3, and I've done this in advance. I'm going to just pull it up real quick here and show. This goes into a calibration file, which I've already generated, and as you can see, target 3, it does not have this capital D attribute. So the destination laser system would note that, and it would omit that point from its drift calculation. All right, so I just want to also indicate the tool surface. Go ahead and do that. Got that in the tree here. As soon as I click on that, I get a red arrow on the screen, get a couple little green arrows too, but the red one is the draping direction. And so the way this works is it's going to look at the composite stacking, the first ply group that it sees here, and in this case I only have one, it's going to pick up that information. So the fact that this arrow is pointing up in the correct direction for my ply layup is because the ply group has been defined like that. I can change it if I like. I can override that. But I want it to be pointing up. And first thing to notice on the screen here is that on that laser projector, the gray rectangle there, I've got my compass, known as a robot in 3D Experience, but in V5 known as a compass. I can move this around at will because I've not predefined any laser projector. I have all manual control over where this might go. The compass rests at the eye of the projector, by the way. So the software will also automatically position this. It'll do this by performing an average calculation based on the minimum maximum distance that's defined within the properties of this laser, taking into account the target points. So these properties are shown over here on this tab. There's the minimum and maximum distance. Here's the projector type undefined. Also, we get some other things here. We get the maximum limits of the laser and then the size of the laser. So if I choose a predefined laser, which I have here as lasers A, B, and C, you can see these values are going to change. So laser A has a range of 1,500 to 5,000, and C would have 2,500 to 7,000. So I'm going to stick with laser A and go back over here to the position tab. I'm going to click this button that says reset position. So it's going to let CATIA do that calculation, and it's going to pull that laser down into an appropriate position. All right. So before I close this dialog box, I want to point out the display options here. There's some nice hide show commands that allow me to control what's visible on the screen. Firstly, I have the ability to hide show the vectors. Not as impressive if you don't have ply contours. We simply have target points right now, so that's why we're just getting 6 little green arrows. But this will matter more once we get some contours on the screen. The laser rays can be turned on and off as well as their color changed. This is nice if you have multiple lasers. Okay, so I'm going to stick with this purple color. And here are is the graphic representation of those horizontal and vertical limit planes. I'll try to zoom out, give a better view of this. And if I were to drag this laser to a manual location, as soon as it gets outside that range, you can see those rays turn red. So that's a nice way to be able to visualize that. All right, so I'm going to turn those back off. Close this, go back over to my position, and do my reset. Okay, I'm happy with that. I'm going to go ahead and click OK. And here it is in the tree. I'm going to give this a name that's consistent with the other two. And I can even reorder that. And notice if I expand the branch, we've got the XYZ and the IJK values for that laser. All right, and before I move on now to to generating some export data, I want to jump over into the tools options of CATIA and just show where those lasers A, B, and C actually reside. So if you have this license activated under mechanical design and under composite design, you get an extra tab, laser projection. Got some various things going on here, but down at the bottom is the one I'm concerned about at the moment. It's the predefined laser projectors. Simply just a text file. I'll go ahead and copy the path here. Open that file up. There it is. So you can add as many as you like. And so these are the fields that define a laser. All right. Cancel this. Now let's work on the data export for this part. Before I get over there, I want to spend just a couple minutes interacting with the spec tree. I'll use this as an opportunity to show what it is that I'm actually concerned about projecting and exporting. Within the stacking, where again all the composite data is collected, CATIA has some nice visual filters to be able to control what's seen on the screen at any one time. Anybody that's familiar with composite design should know that there's quite a bit of wireframe geometry that goes into defining and surface that goes into defining a laminate. Metallic parts are typically concerned with building solids. Really not the focus for composite parts. It's not uncommon for a fully defined composite part to not have any solid at all. Really, you'd have to have a DMU requirement to drive that. So there's a lot of wireframe and surface data, and that's why there's some nice controls to be able to turn that on and off. If I right-click, go to the contextual menu of the stacking, I can show my contours, 3D contours. Those will pop onto the screen. And it's a simple part, but you can tell that as you get a couple plies beginning to overlay on each other, things start to get a little jumbled. The colors here are indicating the fiber orientation. So in the composite parameters, my orientations have been predefined. And so we've got yellow and like a turquoise color. Yellow is our 0 degree, and the turquoise is 45. Cancel that. And notice that when I showed those 3D contours, I also got this part also has a piece of core. So I get that on the screen as well, and that's defined and visualized by its own solid, which is right here. Also, you could visualize, if they exist, and they do for this part, the flattened contours. So the flattening has already been performed for this part. No nesting, simply just the flattening, and there they are, ready to be sent out possibly as a DXF format. Okay, So let's clean this back up here. Go ahead and flip those off. And one nice thing to have is the ability to expand this down to a particular level of data. So under tree expansion, I can go down, like for instance, to the plies, and now I get the sequence of how the part's going to be laid up. So as you can see, most of these sequences have a single ply. Some of them have multi-ply. I can actually go down to the cut piece level as well. And again, cut pieces being the way CATIA represents splicing. And so I can see here that ply 1 has cut piece 1, 2, 3, 4. And I get a nice highlight when I click that in the tree, and I can see that cut piece 1 and cut piece 2 actually overlap across their splice curve. So right there. All right. I'll hide my contours again. It says I'm back online, so I apologize for that.
You are back. Very good.
Okay. Hopefully you can hear me again.
Yes,
Sorry
we got
about
you.
that.
All right.
Okay. Yeah, it's a little bit of a wonky connection, so I apologize. It may happen again, and I'm keeping an eye on it. It's just a brief interruption when it happens. Okay, so hopefully we're back at the point in which I lost you, and I have not moved on, so I'm going to go ahead and continue. So we have the location of where our entities are going to go to, and we have which laser projectors do we want to project, and we're going to leave these checked here, all 3 by default. Go ahead and minimize this. What do you want to export? Let's take the whole stacking. As soon as I do that, this panel expands. And I start to see elements on the right-hand side that we're going to export. So I do have control over what axis system, what rosette that I want to use. I only have one here, so I'm going to just leave this alone. And below that we have now, this is where the control over the laser discretization is. Going to leave this on automatic. I don't really want to fiddle with this too much, but what this is very similar to, it's tessellated data. It's very similar, if anyone's ever worked with an STL file, you have a triangulated approximation based on sag and step, and we have actually a third parameter here, angle. So I'm going to leave this alone, leave it on automatic. Below that, we have our core sample scope, and so this is our ability to determine and let the software calculate the plies being projected at a particular elevation. And so this is going to calculate all the levels below the ply, below the current ply, and it also will take into account core. So this works together with the switch down below material thickness, whether or not it's going to look at the cured or the uncured thickness of each ply and each layer. And lastly, the ability to invert the stacking. So once I click this, I'm going to toggle this. You're going to see on the right this is going to change. Currently, it's just representing what's defined in the CATIA model. So we have sequence 1, ply 1, cut piece 1, 2, 3, 4. Go ahead and check this box. Now it begins with sequence 11. So it goes 11, 10, 9, 4, 3, 2, 1. So I'm going to uncheck that. Okay, and again we have some display options, pretty much identical to when we're defining a laser. One additional thing, the ability to change the color of projected elements. This comes in very handy to be able to sort out visually what is a laser array, what's a contour. So I've done that already in advance, going to leave that alone, click close. Okay, so I'm going to scroll and try to get both of these on the screen here. Temporarily going to turn off my spec tree just so we can see things better. So now I can go down the list here of my elements and interrogate these, get a better idea of what's going on. So starting with ply 1, cut piece 1, I can see that it's going to project a rosette and a contour. I'm going to click rosette, and we can see that that rosette is being projected with the laser on the right, which I do believe is my 60-degree laser. The contour, however, requires 2 lasers. Why? The rosette resides well within the center of the tool. So I'm going to zoom in here, and we can see those green laser rays. Here's our normals, those little arrows that I mentioned earlier. I can change the size of these if I like. I'm going to leave them alone at the moment. And we get that purpley color for the object actually being projected well within the tool, in the center of the tool. However, This contour it's not the case. So the contour actually climbs up the wall, the side wall of the tool. And so the reason that it needs more than one projector is if you take a look at this one, try to look at it from its viewpoint. Start to, I don't want to make anybody air sick here as I move around. But I'm going to zoom in and try to, whoop, sorry. Okay, so I'm approximately looking down as that laser would see the part, and you can see that it's obscured. The side of the tool obscures the contour. So one laser can't fully see the entire contour. So it does a calculation to figure out what's our best way to project, which laser heads do I need. There we go. All right. So, and that's going to be the case all the way down the list. So scrolling down through, you can see. All right. So if I take a look here and say, what if I turn off a laser? So if I turn off 120 and I recompute, what's going to be a little easier to see now that I've done this is the fact that CATIA can't actually do this. So I no longer have this 120-degree laser. It's using the 60. It needs another one, so it uses the 90. But in this case, the 90 is directly above that tool, and so zooming in gives me some of the colors now. I no longer just have green normal vectors. I actually have yellow and red. So yellow indicates that it's probably going to have an issue. It's getting within the limits of the projector to do that, and red says I can't do it at all. And the reason for that is the sidewall is pretty much parallel to the path of that 90-degree laser. So that's a nice way to be able to tell visually, is this doable or not. And all the way down we see that's probably going to be the case for all the cut pieces. So turn all three back on, go ahead and recompute, and we're back to green. Green is good. Okay, now one more thing to point out as I'm scrolling through this list, look at the top of my CATIA screen. It's telling me how many points it takes to be able to do each one of these. And so the idea here is the laser, and again, that's the discretization. The laser is going to, for this particular cut piece, require 73 points. It's going to trace through those 73 points at such a rate that to the human eye, when this happens in the physical world, that looks like a continuous beam. So I'm actually going to close this. I'm not going to export from here. I'm going to close this out and save my part. And I'm going to use this as my opportunity to jump over to 3D Experience. Okay. So things work differently in 3D Experience for anybody that's, for the uninitiated. There's no more file system. Let me just find that here from my list. Here we are. There's no more file system. We're working in a database now. So I need to import this V5 file into the database. I can do that no problem. I would go up here to where I import content, and I can pick CATIA file and browse that file. Here it is. And I get a little panel here with some options. Click OK, it'll go right in. I'm going to cancel this. In the interest of time, I don't have the luxury of waiting for the couple of minutes that's going to take to import. I'm going to use this as an opportunity to show off the search capability. So if I go over to my content, since I've already imported that in advance, I'm going to search for it. So 3D Experience has something called 6WS tags. Who, what, why, where, when, and how. How begins with an H, but it ends in a W. So there are 6 Ws. In advance, I went ahead and tagged my file Y webinar. Easy way to filter down. There it is. So if I look at a preview here, thumbnail view, yeah, that looks familiar. And so I can go ahead and we'll open this up. Oops, sorry, wrong box. There we go. By the way, I can view the properties of it without opening, which is kind of nice, and change them. Okay. Get a little preview. Okay. Go ahead and open. I didn't model this data, shame on the person who did. They modeled it laying on its side, but that's okay. I have a custom view here. We'll bring it up right real quick. There we go. And apply my custom view. There we are. Okay. Try to deal with my screen resolution here. I realize it might be a little difficult for some of you to see some of this text as it gets smaller. Okay, so I've got this open in 3D Experience now, and at the top I can see that I'm working in the Composites Manufacturing Preparation application. I don't need to worry about selecting shareable licenses anymore like I did in V5. So if I have a particular role assigned to me, and I can view my roles here, whatever licenses I need are going to be associated with that role. So I do have the proper role, got the proper correct applications to go with it, and so I'm ready to go. And if I look over here in the CATIA space, everything's collected down here in this ribbon. Under the Composites Collaboration is where I'm going to find my commands that I'm concerned with today. So here's my additional geometries, stacking text, and I get my 3 laser projector commands on the data export. So back to where I was for doing this export. Before I jump over to that dialog box, I want to include some of this additional geometry. I want to put maybe a curve in here and put some text in. So I'm going to do that starting with the text. Launch the command. And what do I want to do this on? Let's just do it on ply 1. Let's pick the cut piece for ply 1. Go ahead and expand my stack. Okay. And so I'm going to try to zoom in a little bit here, a little better view, so you can see how this goes. And I'm going to type something out here in the field. Before I do that, notice that it picks up the support, the tooling surface as a support, and now it just needs a locator point. This is common functionality in CATIA to, if you get to somewhere and you realize, oh, darn it, I don't have a locator point, you can make one on the fly. So I'm going to go ahead and create a point. Just going to toss that in generally where I know it needs to be, right there. Click OK. Now I've got my point. So now I can begin to type, and it's going to be dynamic. It's going to happen on screen as I do it. And I'm going to say, hey, this is, I could say this is cut piece 1, but if I hover my mouse over the box here, I get a little reminder that I can actually use keywords. So these are going to extract information from the file so I don't have to type it out, and it'll be a dynamic link. So I do have a cut piece operator. I got a ply operator there too. Go ahead and use those. Watch on screen as I type this out. Cut piece. As soon as I hit that last symbol, it just changed. So now it's picking up what it's represented to be in the tree. I could continue on just to illustrate what I'm doing here. I could say ply. There we go. If I want to change the angle, I can certainly do that all the way around 360 degrees. Keep that at 180, and I can change the size if I like. Down at the bottom of this dialog, there's 4 options here. The first option is to tell the laser, just go ahead and project that on the tool. That's the 3D. Oh, and by the way, there's another switch to whether I want to actually see that in my model. Yes, I do. Do you want to project it on the tool? Sure. Do you want to project it on the console, which would be this one? The next one is the same as projecting onto the console, only it's going to query the operator to validate. And the 4th option would be if the shop has a marquee, an LED scrolling marquee, it'll project this information on the marquee. I'll leave it on the 3D setting. Yes, I do want to take this into account. Click OK. All right, so there's my stacking text, and one more thing, I will add some additional geometry. So while I'm here, go ahead and put it in cut piece 4. We'll click additional geometry, just call it geometry. Want to take it into account? Yes, I do. All this is going to do is give me a geometrical set. Okay. So within this geometrical set, I can put anything I want. So I'm just going to be expedient here, jump over to generative shape design. And just do an extract. Just going to do an extract, basically the center line of the tool. Whoops. Had the wrong selection picked. Okay. Just select that, hit OK. Boom. Now I have a curve. That's all I needed, just to have that there in that geometrical set. I'm ready to go. So now I'm going to hit my, go back over to my manufacturing, composite manufacturing prep, do my export, click my stacking again, get back to where we were in V5, let that compute, all three lasers taken into account, automatic discretization, take the stacking, vertex, all right. So now when I look at my elements list, and again, got to get creative here with the real estate. Okay. In my cut piece 1, I have an extra branch. So now I get my text. So I got my contour, my rosette, got text. It doesn't seem to highlight when I click on it, but down here on cut piece 4, we get another branch, additional curve. And there it is. So I can go ahead and export these results out, which I'll go ahead and do. Just give it another compute, hit the export, go ahead and overwrite. It says no core sample has been computed. I have this turned off just to, again, save time. It takes a little longer to compute with core sample. Yeah, I'm going to go ahead and export without that core sample. Replace my existing files? Sure. Give this an opportunity to write this out. Okay, that was successful. Woohoo! One more thing before the next step, I wanted to read this back in. I just want to point out for this text here, I'm not suggesting that you have to do this for every single ply manually. I just wanted to show off the functionality in the preferences. We have the ability to include projected text on every ply and cut piece. So if I had that checked, again, there's those keywords. I can put that information there. It'll do that automatically on every ply or cut piece. Okay, so I have my exported data. I'm going to lastly use the imported file reader. I'll do this first in 3D Experience, and then I'll go back to V5 and do it there. So there's my file that I wrote out. Go ahead and read that in. And there's that data overlaid onto my model. Again, text, contour, curve. All right, and I'm going to do the same over here in V5, so cancel that, jump back over to V5, and bring that same data into V5. And what's nice about having this, so again, data that's been generated with 3D Experience, written back into V5. You get a visual confirmation, visual validation of this, and what's also nice is you actually do have the ability to measure to it. So if I go over here, say measure from there, let's say to there. It's hiding underneath the table. There it is. So you get visual validation and a measurement validation. Okay. So that concludes the live demo part of this. I'm going to go back over to my PowerPoint and just give a quick summary of what we've talked about. All right. So in summary, CATIA Composites laser projection is suitable for the hand layup of fabric or unidirectional tape. It's fully integrated into V5 and 3D Experience. It can help you reduce or eliminate ply books, and it is compatible with Vertex, LPT, assembly guidance, and LAP. So with that, I will thank everyone for their time, and I will open up the call to any questions.
Great. Thanks, Kevin. That was a nice presentation. At this time, we'll take your
Thank you.
questions. Please enter them in the questions panel in your GoToWebinar screen if you have one. We'll give you a minute or so. We have one that just came in, Kevin. We have one that's, they're asking, can laser projection be used for things other than composites, such as paint templates?
That's a great question. Okay, so it's a bit of a yes and no answer. Dassault is aware of that. So the question is, what we're talking about here is the ability to project plies, specifically for composites. The idea is if you have a laser projector system, if you have like a paint scheme of an aircraft, for instance, could it be used for that? Yeah, it can. And I think Dassault is sort of in a position right now to keep an eye on demand for that and to enhance capability per need. Generically, I can actually do that right here, just with some curves. Very basic. If you're in the laser projection export, it doesn't say it on the screen necessarily, but you can actually, with the right switch flipped, which would be an LA environment variable, you can actually pick that. Just pick any geometrical set. And so without going through any of the trouble of laminate definition or anything particular to composites, it'll simply just project whatever curves you feed it with a geometrical set. So you can see there. So it's a yes-ish answer.
We'll take any.
I have a feeling that moving forward in the future, I just want to follow to clarify my point. I think this will probably make its way into being a more discrete solution, but yeah, that's what we have today.
Okay. Any more questions out there? Just get another minute. Okay, it does not look like we have any more questions, Kevin.
All right.
So at this point, we want to thank you for joining us today. We hope you found this webinar informative and useful. As I mentioned, we will be making this recording available within the next 24 to 48 hours or sooner if we can. So if you have any specific questions, feel free to reach out to Kevin Waugh directly. And if we also invite you to visit Adaptive's website at www.adaptivecorp.com. We have a monthly newsletter, and that can help you stay up to date on some of our latest events and webinars. And I know Kevin has a few planned for 2017, so stay tuned for that. And thank you again, Kevin, for your time today, and thank you, everyone, for joining us. Happy holidays to you all, and this concludes our webinar.